So yesterday we talked about, what did we talk about yesterday? What did we do? Who remembers? That was a long time ago yesterday. Nice, efficiency. I love it. Yeah. What do you mean by that?
Like, if I want to order hamburgers, if I want to order like 7 hamburgers, I don't want to go like hamburger.
Yeah. And mix it up with like hamburger, fries, hamburger, Coke, hamburger. Wait, how many hamburgers was that? Yeah, very good. So you would say, like, I would order, can I have 7 hamburgers, please? And that is one of the fundamentals of algebra. And so it's interesting how you may not like algebra and you may think it's hard, but yesterday you all did that on your own and you thought it was, of course, the right thing to do. Why wouldn't you be efficient? Why wouldn't you group things that go together? Why would you order 4 hamburgers and then a bunch of other stuff and then 3 more hamburgers and then some stuff and then 2 more? Who in the right mind would do that? Nobody. Except for Tariq. We get that. We all get that. But then when we're doing it on a page in math class, we think it's different somehow, or it's harder, or we forget what it is we're actually doing. So today is all about trying to relate that idea that I think you all nailed, really understood yesterday, but relate it to what it looks like on paper in terms of algebra. Okay? So first of all, some terminology. This is only important because I will use some of this language, and but if you ever don't understand what I'm saying, you put up your hand and ask. Or if we're talking individually, I don't understand what you mean by that word. What is that word you just used? So you don't have to memorize this terminology, but you'll hear it from time to time, so it's good to be introduced to it. So this whole thing is a term. 3 times x squared, or 3 times x, because that's what x squared means, right? Something times itself. A bunch of things multiplied together is a term in mathematics. Okay? And sometimes we have 1 term, sometimes we have 2, 3, 4, all kinds of different numbers of terms. Does anybody know what we call the number at the beginning of a term? You've probably heard the word before, but okay. Anybody want to just guess? It's called a coefficient. It has the word efficient in it, but it doesn't really have anything to do with being efficient, I don't think. Has anybody ever heard that word before? Coefficient? Yeah, maybe you've heard it before, but maybe not, or maybe not really expected to use it. If you forget this word, that's okay. Even if it's on a test, it'll say, like, circle the coefficients. If you don't know what that word means, you can ask. Okay. Coefficient. That was probably too fast, right? Oh, thank you. That's why you can't sit. I wrote it down. Coefficient. The x we just call the variable part. That's pretty easy. It's an unknown value. And the 2 is called, we know this already, we've done it before. Exponent, thank you, very good. Just power your way through it. Oh yeah, here, let me do it. Oh, that's good, I think. Is that good? All right. Now here's the tricky part, but remember what we did yesterday, tie it to our understanding what we did yesterday, and hopefully that'll make it easy to remember. 2 terms are like if, everybody ready? They have the same very A bull and maybe more than one, so I'm putting the S in brackets, like variable or variables. Although we won't really see more than one variable in this class, but it's possible. They have the same variables with the same exponents. And again, if it had more than one exponent, they would all have to be exactly the same. Okay? Determine if each set of terms are like or not like. So for the first two, 3y and 2x, are these the same? Are they not the same? Not exactly the same, but would we call them like terms, or would we not call them like terms based on that definition, based on the activity we did yesterday? What do you think? Why not?
Because one has X plus Y.
Good. So no, because they have different variables. Can somebody give me an example of what this is kind of like to explain, like if you were trying to explain to somebody else why those aren't like terms, what would you say?
You can't add an apple and orange together.
Yeah.
You add apples, you don't add it.
Yeah. What is 3 plus 2?
5.
So you're ordering 5 what? Hamburgers and fries. Well, how many of each do you want 5 of both? No. 3, 1, and 2 of the other, right? Like you got to say, oh, I want 3 hamburgers and 2 fries. If the y was hamburgers and the x was fries, that's what a variable represents. Every variable now these represent a number. Y might be 2 and x might be 3, but you can always think about them as apples and oranges is a great example. Cats and dogs, hamburgers and fries, because that's what we did yesterday. Like you can always think about them like that. You can't add them together. They don't go together. One is hamburgers, one's fries. Next one. Are they like terms? Yes. Why would somebody think they're not like terms? Because they have different numbers. What's the word for the number in front of the variable? Coefficient. Good. Try. Coefficient. They have different coefficients. One's positive, one's negative. That doesn't matter. They will have different coefficients. That will happen all the time. It's the variable part that we're looking at. Next one. I want you to guess. Use your pencil and write it down. Caleb, what do you think for this one?
Yeah.
Caleb says yes. How many people agree? Caleb, why? Same variable and same exponent. They're both x squared. Very nice. Okay, what about the next one? Again, you can guess if you want. If you guess and you guess wrong, make sure you change your answer. Tariq, what do you think for this one? You had your hand up?
It's not.
So these are not like terms. Why?
Because it has an
Yeah, very good. One has an exponent and one does not. Does anybody know? So different exponents. You don't necessarily always have to explain why, right? Like we're gonna do stuff with like terms, but you have to be able to identify like terms first before you can do stuff with them. Does anybody know when there is no exponent, what does that mean? It's a 1. So there is actually, it does actually have an exponent, but we don't write it. So if you just say it doesn't have one for now, like that's totally fine. But it does have an exponent, the exponent's a 1. So if one of them has an exponent of 1 and one of them has an exponent of 2, they're different. So they're not like terms. What about this one? This one's tricky because it's got 2 variables in each and exponents. So what's going on here? This is a kind that we won't actually see very much of in this course, but Cole, what do you think?
I don't think so because the exponent is in a different place than the other one.
Nice job. So this one's a no. Because this one I have 1A and 2 B's, and this one I have 2 A's and 1 B. So they're different. They are different. This is like a poutine because it's a big fry, and this is like a Big Mac because it's like a double patty burger or something. I don't know, right? So they're like maybe they're both kind of hamburgers, but they're different burgers. So you still can't order them together. Does that make sense? Maybe that's a bad analogy. I don't know. So no, because they have different variables again. And so if we look at the last one, what do you think? These are like terms. They both have x, y, x to the 1, y to the 1, x to the 1, y to the 1. Again, different coefficients, different numbers. That part doesn't matter. Any questions about that? Does that make sense? A couple of you weren't here for the whole, or for any of, or the whole activity we did yesterday. So when we talk about hamburgers and French fries and that kind of stuff, maybe you're not quite with us, but okay, I want you to try this on your own. Everybody can come up with 2 different ones. State 2 terms that are like to 3w squared or 3w to the 2. Go ahead, try to write 2. That's the same term. So like this, that's the term, right?
Are those like terms? The variables, but what else is different? And they have the same variables. They both have ones. Right. So that's what makes them the same. So these numbers out front can change, but these need to stay the same. That's better. See how those are like with the
Ethan G, what'd you get for your first one? 2w squared. How many people think that's a like term with 3w squared? Why? Why? Very nice. Nicely said, too. Same variable, w, same exponent. Spencer, what'd you put? Just give me one. 6 w to the 2 or w squared. How many people think that is like, okay, we're getting the hang of this, right? It's pretty straightforward. Cool. You had an insane one. What'd you put? 5,000. Can you use numbers that big?
Yeah.
Of course you can. A number's a number's a number, right? What if I did this? 1/2 W squared. Yeah. Fractions are numbers. What is a number? A number is a position on a number line. Fractions are on a number line. They're just in between whole numbers. They're still numbers, so they still work.
I did 53,400.
Oh my goodness. 3,400 what?
53,400.
53,400 W squared. What about negative W squared? Would that be good? Yeah. That's like a -1 W squared. Good. This is really important. You can only add or subtract two terms if, finish that sentence, what do you think? Cool? If they're like terms. Very good. That's why we're doing this. That's the whole point. And that comes right back to our activity from yesterday. That if they're like terms, if they're both hamburgers, you can add them together. If one's a hamburger and one's a cheeseburger, you can't. If it's a hamburger and french fries, you can't add them together. Unless it's a combo meal, but that doesn't happen in math class. That's only at the store that happens. Right? Sodas are separate. Apple pie, that's separate. Okay, you don't add any of those things together. You can't add them. You can't subtract them. I was kind of talking about that before, right? So this is called collecting like terms. The only reason we need to know that is because you look at the instructions here. It says simplify by collecting like terms. It just means add them together. When you see an expression like this, if you've practiced and you're getting it, you'll know what to do. You won't have to worry too much about what the instructions say. But if you're ever confused, oh, it says to collect like terms. What does that mean? It means add like terms together, okay? Almost always in mathematics, if there are like terms, you want to add them together. Because of the reason from yesterday, it'll make everything easier. Think about the ridiculousness of that guy at the beginning and then even worse at the end. Remember that second video? Oh my gosh. But at the beginning where he's like, hamburger, hamburger, Coke, Coke, fries, fries, Coke, chicken nuggets, hamburger, hamburger, Coke, fries, fries, hamburger, chicken nuggets, Coke. Ridiculous order. What was it? 4 hamburgers, 5 fries, and 2 chicken nuggets, and 4 pops or something like that, right? Like that's how you would do it. So just like in real life, in math class, we pretty much always will put like terms together. Yeah, what do you think it is?
8x.
How'd you get that?
I did 3 plus 5, which now is 8, and then I just added the variable.
Very good. You got 3 hamburgers, you got 5 more hamburgers, you got 8 hamburgers. That's all there is to this.
Do you have to look for hamburgers?
No. Just because of the thing from yesterday. What about the next one? What's different? Somebody, before you go answering it, Emma, could you tell me something that you notice about this?
There's a minus, so
Nice.
it's going to have to be a negative.
Good. Watching for negatives. What else do we notice? Tariq?
Well, he's supposed to simplify it because there's supposed to be 7 x's and 6 y.
Very good. What else?
There's 2 different variables.
Yeah, like Tariq just said, there's 2 different variables. There's x's and y's, and we got to do them separately. So you don't have to do this in 2 steps, but for your lesson right now, I think you should show it in 2 steps for the first time. I'm going to group them first, and I'm just using 2 different colors because it shows which ones go with which. So I did the y's together, and I happened to do them in blue, and I did the x's together, and I happened to do them in red. If you can just do the math in your head, you could do it in 1 step. And if it's only 4, it might be easy. But if you have a big expression with all kinds of terms, you might want to regroup them first before you start adding together. Notice how I use that word terms. How many terms are in this question? 4. It starts with 4 things. 1, 2, 3, 4, right? Everybody get that? 1, 2, 3, 4 separate things. How many did this one have? 1, 2, right? That's why terminology can be helpful, because we use that word. Okay, Emma.
It's negative 3x plus 6.
2 minus 5 is negative 3. So I have negative 3 x's. I have to give the store back 3 hamburgers? I don't know. Bring them from home and give them to the store? It doesn't make any sense. 4y and 2y is 6y. Got it?
I got really confused because I was like, oh, it wants me to minus. I thought that wasn't a negative. I thought that I was supposed to subtract.
This is an awesome question. And this is a tricky thing about mathematics. It's one of those things that I think some people have a hard time getting past, and that's one of the reasons why they think math is confusing. A negative and minus is the same thing. They're not different. Depending on the question and how it's written, it might look kind of different, but they actually really mean the same thing. They both mean we're going this direction on a number line. If I start at 5 and I'm adding negative 5, I go this way. That's like subtracting 5, right? It's the same thing. So try to practice different kinds of questions, but you can think about that, how actually negatives and minus is really the same thing. Okay, let's keep going. Let's try another one. Whoa, see, we got a lot of stuff going on here. When you come up with a question like this, especially if it's different from what we've done before or new, take a moment and just observe. So look at what there is in there. A and A. Oops, that's not what I wanted. I want a highlighter. B and B. And what about these ones? They have no variable. So they are like each other. They're like terms, but they don't have a variable part, but that's okay. So we still add those together. So this is going to be 7a plus 4a. And notice that the sign always goes with the term. So this is minus 2b. It's still minus 2b. Minus 3b. Minus 4 plus 5. Do you see what we did there? So again, we reorganized, we regrouped, just to make it clear. And keeping signs with the thing that they were with in the beginning. 7 plus 4? 11a. What's negative 2b minus 3b? Close.
Negative 7.
Negative 7. Where's 7 come from? Use a calculator. So this is where, folks, this is where, if you're not sure, and sometimes you make mistakes with integers, use a calculator. On my calculator, I go negative 2 minus 3, and it tells me. But if you look at a number line, okay, here's my number line. I start at negative 2, and I go back 3. 1, 2, 3. So that's negative 3, negative 4, negative 5. And then negative 4 plus 5, this gives us 1. Any questions? Okay. The back page, I want you to start with question number 1. I'm going to let you work on that for 10 minutes, and then we're going to do some more stuff together, and then you'll have more time to work.